Calculating molecular mass, sometimes also called gram formula mass or molar mass, is essentially just adding up the masses of all the atoms in the compound. So we're going to do this for water right now, but I'm going to do the long drawn out method so that you can see it prior to doing a harder one. So this is building off of counting the atoms. We looked earlier at how to figure out how many of each atom. We have 2 hydrogens. Even though there is no subscript, there's 1 oxygen. So for hydrogen, we have 2, and oxygen, we have 1. So we're going to multiply that by the mass of those elements. So we're going to look up their masses here in the periodic table. It's in the upper left corner. If you ever forget, look at the key. And we typically round those to 2 decimal places. Sometimes they'll have you use a whole number, but it's a good practice to get into rounding it to 2 decimal places, since sometimes you'll have to do that. Rounding to a whole number, while it's easier, may not help to prepare you. So for hydrogen, we'd round to 2 decimal places. Right now it's a 0, but remember you have to look to the right, and based on that either round up or leave it the same. Since the next number is a 7, we're going to round that up. So the mass of hydrogen atoms is 1.01. And then for oxygen, this one's a little tricky too. You can see it's 15.99, but if you look to the right, there's a third 9 there. So we're going to round that up, and when we do, it'll end up being 16.00. Now you're multiplying that by how many of each that you have, so that makes this 2.02. There's only 1 oxygen, so 16. So we just added these together. So the gram formula mass, molar mass, molecular mass, whatever you want to call it, is 18.02. You could express this in AMU, which we've done in the past for mass of atoms, or you could express it as grams per mole. It's actually spelled M-O-L-E, but we abbreviated M-O-L. And we're going to get into moles a little later on, so it's a good place to start with that. All right, let's do a little tougher one. All right, so now we're going to do this for magnesium hydroxide. So we're going to count our atoms first. For magnesium, we have 1 atom. Oxygen, remember this 2 gets distributed through the subscript. So oxygen, we actually have 2. And hydrogen, we have 2. And then we go ahead and look up their masses. So here's magnesium right here. It's 24.305. Now we're going to round to 2 decimal places, which means that 0 should be our last number, but when we look to the right, because of the 5, we're going to round up, and this becomes 24.31. We just looked up oxygen a couple minutes ago, and same thing with hydrogen. So now when we multiply, we have 24.31 still, 32, and 2.02. Now all we do is add them up. Get that. And when we do 3, that's an 8, 58.33 grams per mole. And that's how you calculate GFM, or molecular mass, or molar mass, whatever you want to call it.